Hi team, Coach Alexa here. I wanted to talk in a little bit more detail about heart rate today and how it's sort of calculated, all of these zones and maximum heart rate, etc., and the accuracy thereof. Now this is coming from two different perspectives. I had the privilege a few years ago of coaching a cardiologist for a couple of years. Very interesting and enlightening conversations we had about heart rate, as you can imagine. And also a lot of research that is out there that I've read up on around heart rate calculations, etc. So the first one to say is that the maximum heart rate calculations, there are a few different formulas out there. But the most common, popular one, I guess, is 220 minus your age is your maximum heart rate, are only accurate for about half of us. So this is because, a lot of research is done, quite rightly, on large numbers of people. So we don't want to publish a whole research paper just based on what happened to 5 people, because if 1 or 2 of them were a bit kind of spurious or, behaved differently, then that would skew the whole research. So you want to do research on big numbers. The challenge with that is that the conclusions it reflects back are an average. And the one thing we can say about average is that there are very few people that are average. There's a whole spectrum of difference in human beings, and there are actually going to be very few who sit exactly on that average line. So when it comes to maximum heart rate calculation, for example, that's only accurate for around half of us. So we often have what's called a bell curve of the average people, and there are quite a few people clumped around the average, and then there's this sort of spread out of numbers of people either side, people who are higher or lower. So for maximum heart rate calculations, half of us fit in about 25%, half of a half, so 25% of us fit in much lower than the maximum heart rate calculation, and the other 25% much higher. So, all of the calculations that, for example, your watch is doing on heart rate is based on a potentially flawed calculation. Some of them self-learn now, which can be a little bit more useful. I guess then there's also heart rate zones, right? So you take your maximum calculation that's come from this slightly flawed formula, your resting heart rate, which often a lot of watches can measure quite accurately, particularly if you wear them as activity trackers all day. And you basically carve up the difference between resting and maximum heart rate into percentage chunks. And again, the assumption that's made is that your cardiovascular performance is a straight line, a linear progression between resting and maximum heart rate. And again, when you look certainly at the runners that I've worked with over the years, and also into the evidence, that's an average. So some people will have a much naturally bigger endurance base, and they'll have to work harder, much harder, to get their heart rate to peak up into those higher zones. Other people, it's quite easy for them to get their heart rate high, and then it's more difficult for them to actually hit manage that heart rate lower, and it's much easier for them to get up to the higher heart rates much more quickly. Now, some of that is just how we're made, how we came out of the box, so to speak. And some of that will change according to training. So if you're training for a faster mile, you'll be more likely to, get up into those higher heart rate zones. If you're training for a marathon, you're more likely to be concentrating on that endurance base, the lower heart rate zone side of things. So again, we are an experiment of one. We are one individual that sits somewhere on this sort of average curve, and you might be in the bit that's close to the average, or you might be on one of the edges. The other thing to, as I say, just reiterate, is the fact that it changes with training. So the more training you do, or the more different types of training you do, more speed focus, more endurance focus, your performance and heart rate zones will change. And also it changes with age, it changes with health status, lots of other factors that will change over the years. So heart rate zones are not set in stone, even if we do find the accurate ones for us. And the only way really of finding out your accurate heart rate zones on a particular point in time is going to get them tested in a laboratory. That's the only kind of way of getting them accurately and definitively, but then again, that's a point in time, and they will gradually change as you train and as you age, predominantly from that point forward. So talking about laboratory-based testing and accuracy thereof. There's a couple of other things that Garmin in particular, a lot of the other sports watchers like to give you some feedback on. They like to start estimating your VO2 max. They like to start trying to estimate where your lactate turning point is, etc. And it's quite straightforward to say that the watchers do not know where those are. The only way you can find out what your VO2 max is or what your lactate turning point is to go and get tested in a sports science laboratory. Again, it's a point in time, so that figure will then change going forwards. What Garmin, for example, are doing is taking your training data that they do know about you, and the only things they do know about you is the time, the stopwatch, your GPS location, which gives them distance and then therefore with time pace, and your heart rate, assuming that your heart rate is accurate, because wrist-based heart rate monitors aren't particularly accurate. So that is all it knows about you. Oh, and elevation. Be able to work out elevation either from the map or from an altimeter in your watch, and cadence if it's got an accelerometer in it. It does not know your VO2 max, so the way it's guessing your VO2 max is by taking the information it does directly collect about you and comparing it to a big bank of data that it bought from some laboratories and reflecting back the average VO2 max from that bank of data. So it's important to make that clear, because I don't think, just taking Garmin as an example, because I have one and lots of my runners do, they don't make it clear in their interface what is data that they've actually captured about you and what is data that is being through this sort of estimation guessing algorithm. So it's worth knowing that, and it's worth bearing that in mind. I'm not saying that the VO2 max calculation isn't a useful one. Tracking the trends can be useful. I will say that Garmin and Strava, I've certainly noticed, favour speed work over endurance work. So I've worked with a runner recently where we moved from going from a fast half marathon time, where Garmin was very pleased with her training status and her VO2 max. And when we went into ultra training, it told us quite a lot that she was detraining and that her VO2 max was decreasing, and it's just because the algorithm favours speed work over endurance work for reasons that Garmin have decided. So, you know, that it's worth just knowing about where these numbers come from, how they're put together, and what to read into it. Another test that I like, a more real world and sort of personal accurate test, is setting somebody the same run. So ideally the same distance, the same pace, the same route in terms of, you know, elevation, etc. And ideally, if you can, similar-ish weather conditions, maybe 2-3 months apart, and see if there's a difference in heart rate. So you might be the same heart rate but you've gone faster, or you might be the same pace but lower heart rate. That for me is a big enough indicator of improvement in cardiovascular efficiency than anything else the watch might be saying. So, couple of takeaways, I guess. All of these figures that your watch gives you around heart rate zone, VO2 max, lactate turning point, there is a level of inaccuracy in terms of those zones, those maximums, and some of the calculations that it's then making off the back of those. So, you know that, bear that in mind. We are all experiments of one, and we're being sort of filtered through these calculations and this algorithm that assumes it's one size fits all, which is not the case. Hope that's useful.